as the title says, it's Bowtie risk management, the basics. I'm just going to talk about barrier thinking today and what a bowtie is. Excuse me. And so I'm not going to go into a massive amount of depth, but I appreciate you may have questions at the end. So please, as Isaac said, pop your questions in the chat. I can't see it from where I am because I'm looking at my notes and trying to sort of follow my train of thought, but we will come back to things at the end. I'm always happy to take questions. And a little bit about myself. I'm 𝘁𝗵𝗀𝗀𝗀. I'm a safety engineer. I started out as a mechanical engineer, I think 27 years ago, which is worrying. I've got a master's in safety critical systems engineering, and I spent the first 19 years or so of my career in military aviation. So design, manufacture and maintenance of fast jets, some involvement with heavies, and a little bit of involvement with drones, which has come back in of late. But I'm not exclusively aeroplanes. I've had great joy in going out and looking at rail infrastructure, critical national infrastructure, sort of water plants, road and rail, and other sort of exciting things. And one of the great things that I've learned is risk, safety, it's all the same. We just use slightly different languages from business to business, industry to industry. And what I've loved about bowtie and barrier thinking is that it just allows you to simplify that for everybody and center things around a picture, which is always useful because a picture paints 1,000 words. So I always start my presentations with this slide and these three sort of questions. Sadly, not mine. I wish I was sharp enough to think of these things, but post Buncefield accident in the UK, which I think was the third largest peacetime, or in the top 3 explosions in the UK, and certainly one of the biggest in peacetime. After the inquiry that sort of looked into that, the health and safety executive, the head of it, Gordon MacDonald, said on the steps of the court inquiry, said the challenge to leadership are these 3 questions. It's, do we understand what can go wrong? Do we know what our systems are there to prevent that from happening? And do we have information to assure ourselves that those systems are working effectively? And I think these are 3 absolutely solid questions as to A, why you look at risk, but B, and how you look at risk, but B, specifically how barrier thinking helps you approach these questions. So that's really the thread of today, is to explain how, by thinking in barrier terms, we can help answer these questions. And I've got a bit of a sort of academic paper for you. The reference is down there. And really, these chaps said it's about encouraging more investment in safety and making the safety elements explicit. All my career, there's always been a little tick box in the bottom of the incidents and change things of, is safety affected? And it's the box that everybody ticked to get funding. But we need to have some sense, some order, and some reality around this. Often people don't realize what they're doing, the impact that it has on safety, and it can be really inconsequential little things, sweeping up the floor. There was a massive fire at King's Cross in London that was essentially the build-up of waste products that caught fire in a spot that no one could see, that led to a huge fire. And it's as low down as the person sweeping the factory floor can have an impact. When you lay things out in a bow tie and barrier thinking, you can see that quite easily. So it really helps people go, that's important. And when you lay out what you said you were going to do, it helps you very quickly work out what you are not doing. And I think, this is a real reason why barrier thinking can help us. So I've talked about barrier thinking, barrier risk management. What it boils down to is it's bow tie modeling. So what is a bow tie? So I'm going to sort of break down, there's kind of 7, 8 steps to it, depending on where which book you've read, but we always start with the hazard. The hazard and the top event, really, these 2 things go together. You can't separate them in my mind. And for me, this was the big step change in my thinking when I started to understand that the hazard can sometimes, if people just describe a material, there's no context, there's no meaning around it. Yes, you know, these things can be bad. Hydrazine is inherently dangerous no matter which way you look at it. But what and why? I think it's really important to understand the context. So we start with a subtly different change in the definition of a hazard when we start Bowtie modeling, because we talk about it being the things that we do that is normal to our business that has the potential for harm. So we're actually talking about doing something, and then the top event is the description of how we lose control. So I come from an aviation background, and I have my little aeroplane here. I'm going to suspend that at 38,000 feet. I'm going to put lots of people in it, and I'm going to fly from A to B. And I've got two engines in this one, and I've got lots of routes where this could go wrong. And I'm specifically interested in how it goes wrong and what I will do. If I have an engine failure, I've got another one. That's why there's two on commercial aircraft. And that allows me some level of control that I can manage the situation. If you work in a 𝘁𝗵𝗶𝘀 top tier site, it's typically around release of something bad, something dangerous that you need to manage. So you need to be able to demonstrate that I understand why I have the risk, the hazard, the danger associated with it. And when I'm thinking about the loss of control, I understand where my bad day starts. I don't go to the end, the explosion. They're still important to understand, but I really want to understand this. We're going to call it the center knot, and you'll see why, of why I have this thing and when it starts to go wrong for me, when it's not in its managed space. And that's a really powerful shift in thinking. It's very subtle, but it has a very big effect in the way you start to think about your hazards, your risks, and the things that you're doing. So I mentioned the consequences, the harms. These are the things that are why we are managing it. I'm actually going to say something sort of challenging, is that I'm actually not that bothered. I need to understand them as context, but if I measure these things, if I'm worried about how often they occur, it's a bit of a false sense of security, because we're generally pretty good at managing things. So once it's gone bad, once it's happened, this is not helpful for me. I'm more interested in the point at which I lose control, and we'll come back to that in a moment. So once I've identified the top of the hazard and the top event, I need to identify my consequences, the things that are negative outcomes that are caused by that thing if we don't do something, that loss of control. So really important part of our understanding, but I want to focus on the other side. Oops, wrong way. And talk actually about the causal events of that loss of control. This is where the real power, I think, of barrier thinking is if I understand what will lead to my loss of control and I understand the consequences, I can have a greater effect of managing this issue by managing the threat rather than trying to manage the consequence. By managing the threat, I am actually managing the consequence even better. And then we have two flavors of barrier. From a modeling perspective, when we put them in a tool, they are the same thing really. But the preventative barriers, this is the bit that I'm talking about on the left-hand side of the diagram over here. These have a massive impact, because if I have a threat, this could be a state, a change in weather, a failure of something. If that occurs and I can prevent that, manage that situation to avoid this loss of control, I don't get near the consequence. And that makes these really powerful, really useful in our management of day-to-day operations. Now, I talked about 𝘁𝗵𝗀, and I come from an aircraft world. These are industries where you are obligated to be able to recover from foreseeable losses of control. So these barriers are important, but they have two functions over this side. And it's not easy to bring them out in the modeling, although we can use tagging to identify. But I basically have the primary function on a recovery barrier is it gives me control back. It puts me into my normal operating state, and they're good. They're really powerful. But I have a secondary set of recovery barriers that actually sit conceptually on the right-hand side of the consequence. But these are to mitigate or manage the consequence. The fire won't be as big, the explosion won't be as big, we won't leak as much gas. I can land away in my aircraft, so I don't get people to where they want to go on holiday, but we haven't crashed. We've landed safely, just not where we intended. So there are follow-ons from these things, and I have to do things. But the real power and the thing that occurred to me at some stage in my development of the understanding is this is actually a map of your quality system as well, in that here on the left-hand side, this is all the stuff that I said I would do, when I said I would do it, how I said I would do it. That prevents that loss of control. If I'm using my recovery barriers, this is where I'm out of control. So I'm probably involved in scrap, rework, wasted time, wasted effort. This is not doing the job that we set out to do. And that was a real penny drop moment for me, the sort of realization that safety and quality were the flip sides of the same coin. We have to work together. By understanding what I need to do from a quality perspective, I get the required output for my business, but I can also inject where the safety, the risk element comes in, and why we absolutely have to do these particular things to protect people, protect the environment, protect our assets. So this was a real thought change for me, and really quite a simple diagram. And this, you can see the shape is where we get the bow tie diagram phrase from. Now, if anybody's heard of James Reason sort of put up the Swiss cheese model, which was we have these layers of defense, these barriers that we put in place to manage the risk and to manage the loss. Unfortunately, nothing is perfect, and he sort of described it as Swiss cheese that has holes in, and if these holes line up, then that's effectively your barrier failure. So I go through the threat, through the loss of control in the middle, through that barrier, and then meet the consequence. And so the final sort of elements of the analysis are degradation factors, and these are things that damage your barrier, things that you know about that can occur. So for instance, on my working from home, on my hall landing, we have a fire smoke detector, and if the battery fails, the smoke detector stops. So now UK laws changed to mandate that we have mains powered smoke detectors with a battery backup. So I can predict the fact that the power may go off or the battery may fail, and by having two sources, I can resolve that. So I have effectively, I have my preventative barrier, that is, I have a source of detection and announcing the fact there's a problem, and I know that if the smoke alarm goes off, I should look to leave the building. And I have the fact that I could lose the power, either the battery fails or the mains fails, but by having two sources of power, I've got redundancy, so I've built in a control. Now, in other modeling tools, you will see little things hanging off the diagrams. With our risk runner, we've gone a slightly different direction, because we're also seeing that barriers are often complex systems, and it helps you to better understand how that system works and how that system can fail. So effectively, we've got a mini modeling system that can sit behind that and allow you to understand these things better, the positive things that are providing the barrier effect and the negative things that are taking the barrier effect away, and anything you may do to control that. So we also think as well, it tidies the diagrams up a bit by not having everything displayed in one place. So those are the core building blocks of the diagram. We start with the hazard and the top event. These things go together. We understand our consequences. We understand our threats. We have the real high value preventative barriers, and we have the really useful and essential recovery barriers that make that smaller or put us back in control. And then we have an understanding of how our barriers, whether they're preventative or recovery barriers, can be degraded, or importantly, how we actually achieve the effects that we're looking for to make those happen. So barrier modeling seems very simple, but I can tell you from experience that getting the hazard and the top event right is the real challenge. And what we've seen as well with lots of clients is often they have a very high focus on recovery barriers. They're firefighting. They accept the loss of control, and they've got very good at picking up the pieces and managing that situation. And working out what you do can be quite tricky to get into this space. So there's a little bit of science and art mixed up in how you build these models, but it's a very simple concept to display. The production is tricky. So there's a set of rules that help you build that. I've also put this slide in because I've grown to really like this as an explanation, a sort of more word model of what bow ties are. So we start with the fact that your safety barriers it's the focus on safety, but actually we find there's a massive crossover, as I've said, with quality and security. So a lot of people are focusing on IT security, cyber stuff, as I've talked about quality, but also business issues. And this is a useful way where you can start to blend in. One of your negative outcomes is you don't achieve the business need that you have, i.e. you don't make your target for production, you don't meet your clients' needs. And that can help get focus into safety, in the sense that you can show that I have to do these things, and by not doing it, it can actually damage the business. So it helps give you that focus into bringing safety, quality, and business risk into the same language. And by having a tool that does this, you can actually help people understand what we're talking about, the same things, coming at them from different angles, which I think is really useful. The barriers, your physical and non-physical, we're often still, despite growing up in the 70s and 80s and seeing all the cool cartoons, the Thunderbirds and everything, depicting the future and how bright it's going to be, we're not living in a fully automated era. We still have people doing lots of things, and it really helps to understand the types of barrier that we have, because people are not great. I mean, no, people are great. People are not consistent at doing things under pressure. So we want to understand where we've got hardware, whether that's dumb hardware or technical, intelligent hardware, and importantly, where people form an important part of the decision loop. So it helps to describe these things and annotate them in your model. And it's planned. It's talking about things that we said we would do. And again, from personal experience, I've worked on platforms that have had a 45-year life, and I suspect that a lot of you on this call work in process safety, lots of industries where the equipment lasts a long time, and the world around the equipment and the products change and morph over time. So we are trying to predict and plan what we're going to do to ensure that it works for a long time. And so we are managing that, and we're managing a change cycle, which I'll talk about in a brief while. So things like resilience aren't really covered in this, although I think there is a link to resilience in that if we're doing what we said we'd do, we've really got our elbows out and we narrow the things that might occur, the black swan events. We really sort of reduce the potential for those. And again, the prevent, control, or mitigate, I think this is really key, is as the accident sequence develops, we have our prevention barriers. These are the absolute gate guardians of what we're trying to use and the control of our operations. Then we have our control barriers, the ones that are on the right-hand side of the diagram, that they get us out of the unwanted situation. They return us to our normal operating state. So if I lose an engine, I still have enough power from the other engine to maintain normal flight, or at least a controlled rate of descent. It's that business about you stay in control. And then I have my mitigation barriers where I'm reducing the damage as much as possible. In the world of aviation that I operated in, they were all single or two-seat aircraft, and we had the luxury, I will call it, of an ejection seat. So if it all goes horribly wrong, the aircrew could leave the aircraft, and it puts them in a different world of pain, but it's not the one that was going to crash. So it takes them away from the problem and reduces the damage. You keep the people alive. And then we have our undesired events. These are the accidents. These are the things that we're actually going to ascribe risk to. We can talk about the probability of that thing occurring. And one of the things that I'm really keen on with Bowtie modeling is it makes you be a little bit more specific. And I think that's really important because, again, experience tells me that if I have a vague bow tie, I will get vague requirements out of it. It will tell me to do things that are not defined, not detailed. As an example, I've worked with high tension, sort of, 22,000 kilovolts rail power lines, and the guys that do that, they really know what they need to do from a safety point of view, and they're all trained in first aid that focuses a lot on how to deal with burns. If you are vague and say first aid kits, that won't drive people to create a first aid kit that is centered around burns. You could end up with something daft like an office safety kit, which has plasters and a bit of eye drops in it, which isn't going to help you. You really need to be specific about how you will injure people, how the incident will unfold, because that lets you know whether your barrier is actually going to have an effect that will, a measurable effect. So really important to have that detail, but it really, the key thing is these barriers, these control measures we're putting in place. This is about the things that we said we would do when we designed the system, how we said we would operate the system, and it's keeping the checks and balances on this. They're being done, they're providing the effect that we want. And I think that's really important for people. So I think this is a useful little slide for you to sort of take away. In that it provides a bit of a word model to the framework that I've given you in the what a bow tie looks like previously. And then I talked about barrier rules. I mean, these are basically just guidance to create a good bow tie. And it's put my book down somewhere safe. It's not our invention. It came out, although we were partly involved in it, the BowTies in risk management. It's a really, I'm going to say, yeah, it's a good book. We're not associated with it really, but it's the CCPS and the Energy Institute wrote a guide. It's the only one that's out there that I'm aware of on how to do bow tie modeling. And it provides these really solid rules that says your barrier must be effective. And this is where I mentioned your barriers are systems. Often people will describe a barrier as the piece parts of the system. So they'll talk about the smoke detector, but actually the smoke detector and the alarm and the knowledge that when I hear the alarm, I should leave the building. That's the barrier, is that we have a detection system, annunciation, and we leave. If I don't leave the building, I potentially die in the building in the smoke or the fire. So when we describe our barrier, we should really be describing the effect, or at least the system that is providing that, and it must be capable on its own of preventing the threat developing. If it's on the left hand side, the prevention barrier, and if it's on the right hand side, it must either give us control back or have a measurable impact on the severity of the outcome. So that's what they mean by effective. And I think this is a really good challenge when you're building your bow ties. We've seen where people have 20, 30 barriers on a threat line, and you just go, either that's never going to happen, or that's not really describing the effects that we're looking for. We need to think about the effect side of it and try and group these things together to go, actually, we only have 3 barriers, they're just complex. The other side of it is independence, and common failure modes is a real thing. If you've done any fault tree modeling, you'll know that this comes out quite loud and clear. And I think it's really useful to have that mindset with this of, are we reliant on the same power source? Are we reliant on the same piece of data? And similar, the smoke detector is very sort of similar in that regard, in that if the sensor doesn't transmit the signal to the horn doesn't go off. So the horn needs some control and some notice from the previous bit. And I need to hear that as well. So if I'm fast asleep with earplugs in, I don't get that message and I don't act. So there is a data flow, an information piece that's transferred from the components of the barrier. So that independence is really powerful. And again, things like power, data, they all appear in there. It's a very strong one to go through and catch those little things that are going to let you down in your modeling. And then finally, auditable. Audit's always an awkward word, because if industry that I was involved in, I had to do process audits on other departments. I think I had to do one a month, which meant I was also getting audited. And then we had first, second, and third level audits coming in from outside and regulators and so on. So we spent a lot of time being audited. This picks up on that, but actually it's really a challenge to say, is there a means to check that your barrier is doing what it will do? Is there a test somewhere? I came out of a world where everything was qualified, everything had test evidence. So we had a lot of that stuff around there. It could just be a performance standard. And if we took fire extinguishers, a really common piece of equipment, they come in standard sizes, so you've got a rough idea of the thermal mass that it can manage, and you've got the all-important little pressure indicator on the front, where if the needle's in the green, you have a huge degree of confidence that when I pull the pin and press the handle, that fire extinguisher will discharge and have an effect. So it's all about, have we got evidence that we can go and lay our hands on to say that barrier is providing that effect. It also ties into the fact that you're developing, most of you have safety management systems, error management systems, failure and investigation systems that are providing evidence of barriers working, not working. And the barriers working is as important as the barriers not working, because it gives you a high degree of confidence you can rely on it. So these 3 rules, really, when you're building bow ties, have a huge impact on the quality of your bow tie and what you can get from it. So I talked about earlier, I said I'm going to sort of a life cycle and the fact that we're maintaining things. And I've got 2 diagrams. I really can't choose between them. It depends on the mood I'm in and who I'm talking to. But I really like them, as they provide a lot of help in understanding where barriers and barrier thinking specifically can help you manage your business. So when you're describing your hazard, the scope, the context, the criteria, what's within the control of my system, what's without, is really important. And so it kind of all hinges around this bit here. And then we have to identify risk. Well, barrier thinking doesn't help you identify risk. That's the sort of understanding of your business, your industry, the materials you work with, the processes you carry out. But when I get to the analyze risk element, the framework of the bow tie helps me understand, because I have those consequences, the harms, and I have a very good understanding of what can cause me to get there. And we can do quantitative, I prefer qualitative analysis. And then the treat risk is really, are the barriers going to provide the effect that we need to? So this is the green line is the design or the change cycle, but primarily it starts in the design. And there's the process safety, sort of the hazard study 0 through 6, they can be aligned with BowTies quite nicely in the terms of I understand the nature of the process and therefore the harms that I will have. I can go through and evaluate and talk about the barrier control interventions I must have. And then I go into service. I'm actually at the point here doing what I said I would do. I'm going to verify my barrier performance. And if it's falling below the levels I've set, I need to change my barrier model, do something new, go round this loop again to check that it's going to provide the effect I need, and then carry on in that maintenance cycle. This diagram is basically saying the same thing. And as I say, I can't choose between them. It depends on mood. But essentially, we are operating in this maintain. I'm monitoring, I'm detecting deviations. I'm working out whether I can live with that or I need to make a change. And I can put the design change in, implement it, verify it's had the desired effect. This is all talking about barriers. And I think this is really powerful stuff, is that by understanding the things that we said we would do and not thinking of the hazard as this big concept, that the hazard is almost irrelevant once you've got your barriers. They're the things you need to focus your effort on. And then what I like about this one is these internal, external drivers, changes. We're making changes to the product. We're changing the environment. We're building a new plant next door. Somebody's built a housing estate next to our factory. Does this change anything in our world that requires a design change that will change to what we do? And we need to check that it's still working. So I think these two diagrams sort of lead into the three questions at the start of the can you verify it's doing what it's doing? So kind of in sort of wrapping up here, the bow tie is not a silver bullet, but what it does is it gives you that visual. A picture paints 1,000 words of the things that you are doing or should be doing. And I've worked in enough and worked with enough people to realize that, oh yeah, we're very good at this. And when you start to scratch the surface, you find there's lots of evidence to say they're either not doing it because they never got the equipment, or it's not working very well and isn't providing the effect we want. And people have found workarounds to make it work, and they're actually doing okay, but it's not the documented process. And I think it's, as the academic bits, the simplification of complex situations, that allows you to have better knowledge. It allows you to pass on that information of the hazards and the controls to people who are doing things. Your shop floor staff are really important in this because they're often the first recipient of the pain when it goes wrong, or the first person to be there and fix the problem. So they need a good understanding of what they do, why they do it. And then by having somewhere to hang, an understanding of that complex situation, but having a place to hang all your data, it allows you to create information that tells you we either don't understand the scale of the problem, we need to put more investment into things, or we don't yet have enough control over our problem. And I think that's the really powerful piece, essentially. And so bringing it back to the questions that I posed you at the start, if we understand what can go wrong, we've effectively defined the hazard and the loss of control. And that, as I say, that's the really big piece of bow tie modeling, where it takes a change in your typical thought process is to push back to where does my bad day really begin? Once you've got that, you can really go to town on defining the barriers. And actually, this becomes quite easy and quite quick. And often, as I said, there was an element of art and science to this, is people have put all the pieces, all the bits, but you have the center not in the wrong place. And kind of going through the process of pushing it back to where you really want to control from helps everybody realize why we don't want to do that stuff on the right-hand side as a matter of course. We want to focus our efforts on getting really good on the left-hand barriers. And then we've got information. We've got a framework that allows us now to verify the specifics of the barriers. So instead of doing generic audit, generic things, we can go very barrier centric to understand the very specific safety elements that we're looking for. And it helps the quality people as well, so they can't really object to it. It really drives us down this path of doing these things well, doing these things consistently. And I'm now going to say something that's a bit mad, to say that actually it's not about the Bowtie model. It's about doing something different with your Bowtie model, with your knowledge that you've gleaned from the Bowtie model. And so you end up in a point where I need to build the Bowtie model to have a good understanding of my context, but then I need to use the Bowtie model to do something different as a result of what I've learned. And I think that's the real power. And that was the thinking behind our software in particular, is we want to bring data together and associate it in a way where you can understand where it sits around the model pieces. And we spent a lot of time working on dashboarding using Power BI, and so pulling data from whatever source and the context of the barrier to give people who need to do things a very focused view of their world. So it's not about hundreds of Bowtie models. It's about building the Bowtie models you need to glue all your various bits of data together to give you information that means you can act appropriately to better understand your world and better control your world. So I'm going to, I think that's really the close of the presentation is barrier modeling. It brings you a different view to the stuff that you're already doing. And I believe it gives you a lot of context and a really good way to answer these 3 questions, which I think gives you a really big boost in the control of your business to allow you to stop doing things that don't add value or safety function and focus your efforts on things that do, which will make you better from a quality perspective as well, which has to be good for business. So I'm going to stop there. I've given you, so that when we send out the slides and you've got these links, you can find our details. You can find me on LinkedIn. Happy to link in with people. And also, if you would like a Risk Runner demo, there's a link there. I think Isaac's going to pop the hyperlink in the chat as well. There we are. And also Power BI dashboarding, if you want to have a look at that. We've got some good stuff we can show you there. And I think we can basically open the floor to questions if people have got any.
We had also a question before from David. He said, he asked, is it sometimes easier to imagine the catastrophic outcome and work back right to left?
Generally, I would say no, but the rules and the guidance is for wise men as opposed to the obedience of fools. A lot of industries, we already have a good idea of what can go wrong, but I would still counsel that you need to think about what it is you're doing and why you're doing it, and then look at where you lose control. But you'll already have an outcome of the typical scenarios and the typical the types of failure. I think by always challenging yourself, you open your eye to the art of the possible, and especially where we've got lots of change going on in the world. So in my lifetime, the use of IT has massively changed how we work. So when I joined a company, I was only sort of 2 or 3 years after everybody getting a computer. And certainly when I went through college and university, you went to the computer room to do IT things. Now we're in quite an automated world. We're all on IT, and we're also in this paradigm shift of everybody wants AI involved in things. So I think yes, you're always going to have a fair idea of the consequence, but I think by challenging yourself to look in the middle and start in the middle and work out, you'll maybe find some other stuff that you've not thought about.
David also responded, like, I'm thinking there is as much value in engaging key persons from an organization, the process, as there is in the final product. What is your experience of this?
In the final product. So I think, yes, David, there's a massive value, I think, of giving people the bow ties. I have seen personally, I've seen people where we've put the bow ties up, we've shown people things, and somebody, it was a guy from the shop floor went, I do that, and pointed to a thing on the bow tie diagram and realized that's where they are. We've also had instances where we were reviewing them with a team. It's always good. I'd recommend don't do this on your own. You need to, it's a collegiate thing, is having the right people in the room. They went, now I get why you're asking us to do these things. Now I see the context. So I think there is a thing of giving people the final product to see and engaging, but very often people need the dashboard element of it. It's there about telling you what you need to know. So I'm a real big fan of, and I know, David, you're a pilot, so dials, I want everything to point up, and when it's gone into the red, that's a bad thing and I need to act. So I want a sort of a positivity page, and if I need information, I want to be able to click back and get the context. But initially I want to know there's an action for me and something I should do. And I've just seen another question about a LARP.
Yeah.
Another way to determine. So this is a really interesting one, Mohammed, that I think a LARP can only be determined when you have an understanding of your system. So, are you doing enough? Is what you have working well enough for you? I don't think you could use a LARP to understand the health of your barriers, but the health of your barriers informs your LARP position by saying, if we said we would do a thing and we're not doing a thing, we're definitely not in the LARP camp. And we've got quite a lot of thoughts and have been working so that the Power BI demo might be useful in terms of barrier health and how to understand and assess the performance of your barriers, because there's an element that relates to the context of the performance of the other barriers in that threat line as well. So we've done quite a lot of thinking, I think moved our thoughts on in terms of how do we effectively measure barrier health that will then inform our position on a LARP overall. And again, Hugh, I'm picking up on your response to the Mohammed's question, and yes, so criticality definitely plays a part. If I have one barrier on a threat line, that's a critical barrier. I need it to work, but I also need to understand the context of how likely my threat is, how often I'm exposed to that risk. So there's a lot of things that need to come together to understand the health of a barrier and the where I need to put my focus, and that whole picture informs my alert position for that activity, that thing that we're doing. And then Hemant's safety critical equipment, there's a really useful bit. I've just talked about barrier criticality. There's a flow chart in it's the Mining Association, possibly one of the other resilient folk will type where the paper's from, but they have a flow chart to help you work out whether you've got critical barriers and therefore critical equipment. But remember, your equipment might actually be a person doing a thing, and it's important that they have either the training, the knowledge, the ability, or the associated equipment that goes with it. So you end up potentially with a system where I need a piece of equipment and a person to operate it. So it's criticality is very helpful and it's much more easy to work out criticality when you have a bow tie diagram for context, and then you use that information to inform my need for critical equipment. Does that answer your question, 𝘁𝗵𝗶𝘀? And I like, David, your point about landing gear pointing down when it's down and up when it's up. Yes, there's some really good human factors things come out of aviation, but generally needles pointing up is positive.
Yeah, and Paul also shared the article, the barrier health article. It's a great article, so feel free, click the link and look at it.
I really would encourage folk to have a look at that, because I think people just assume sometimes that they've got a thing. They're not looking at that thing in the context of the threat and the loss of control, or the loss of control and the consequence, and asking, really, is it doing what I need it to do? We were talking to a client recently where they look at every incident, which is, that's gold standard, but they look at it in isolation as just that incident, and they're not going, have I seen the bigger picture? Have I got 8 other barriers that are functioning absolutely fine, but that piece of equipment failed? So they're giving everything equal attention, which is tiring and diverting you from stuff that really needs a heavy focus. And it's also expensive, because I'm putting the same effort into everything. Whereas, going back to Hemant's point about criticality, is if I've understood the criticality, if I have a critical barrier, I should put more effort into that. I'm not saying that other barriers don't get a look at, but I can reduce those to, they get an annual check and we check all the data and we do it once. But a critical one gets an instant look at and say, are we safe to carry on? Should we still be operating? And I think this is where the bow tie is the contextual framework, and is the really useful thing for you to understand all your data coming out. I think of it as it acts like a filter, and the good stuff sticks to the bow tie. Excellent. Have the questions dried up? It looks that way. Well, I will thank you all for your engagement and giving me a little piece of your Wednesday morning. I hope you found this useful, and yeah, very much encourage you to have a look at the Power BI demo, the barrier health article is a real useful takeaway, and feel free to pass the YouTube link on to your friends and colleagues. And yeah, very much invite you to keep in touch with us. Please link in. Always happy to chat with people. And we look forward. We're going to have another well, we've got a series of webinars. So we will be doing a webinar on our Risk Runner product and how that can bring your data in. And there is definitely going to be a Power BI dashboarding and barrier health webinar as well. So we'll glue all these pieces together for you.
Thank you very much.
Everyone.
Bye-bye.
Yeah, thank you.
Thanks, everybody.
Thanks, Alistair.
Thanks, guys.